SOA exam C sample question number 2. First, I want to talk about the aggregate losses. When individual loss size are IID, the aggregate loss is sum of individual losses from 1 to n, while n is random variable representing number of claims that are number of exposure that has claim, which means number of exposures that have the individual loss that is larger than 0, right? So by total variance and total expected value formula, we can get the variance and expected value for aggregate loss. You can verify yourself. Second, I want to talk about the full credibility. Full credibility, my understanding is at 1 minus alpha confidence level, the aggregate loss will fluctuate between 1 minus k times expected value of aggregate loss and 1 plus k times expected value of aggregate loss, while k is larger than 0, right? By central limit theorem, we can approximate S with normal distribution. Therefore, we have z value times standard error of the aggregate loss equal to k times expected value of aggregate loss. And we normally deal with average number of claims per exposure and average sample size per exposure. Therefore, when we plug in, you will see m bar x bar here. And by central limit theorem, we also know variance of x bar is variance of x over n. Note here. So n here is number of exposure, not number of claims. All right. So when we take n to the other side, we get this, and when we time n with expected number of the average number of claims per exposure, we get number of claims we needed to achieve full credibility for aggregate loss, right? Similarly, we can derive the formula for number of claims needed to achieve full credibility for number of losses, number of claims, and number of claims needed to achieve full credibility for sample size. All right. So note that there's no need to time E capital M. It's because when we look at the claim size, we only look at claims that we only look at exposure that has claims larger than 0. So there's no need. Right? After this, we will be looking at the question. All right. So question. So we just plug in our formula. So this is z 0.95 and our k. Since the Poisson variance and expected value are the same, so this is 1 here, and Pareto, we get the variance, and this is the expected value, and the final answer 16,913.